Hey guys, it's Mr. Jantzen here, your science teacher. Today we're going to talk about density and all about the important properties that involve with density. Density is an important topic in earth science. You've probably learned it before, but students do have a tough time with it. They basically just memorize the formula and then hope for the best. But today we're going to kind of go slow through it and make sure you get a good appreciation for what density is all about. Okay. So real quick, before we go into density, you got to understand what mass is, okay? Mass is the amount of matter in an object, okay? The amount of molecules that make up an object. Obviously, you can see by the picture here, we have a large sumo wrestler with a bigger mass, and then we have a smaller sumo wrestler with a smaller mass. So mass, obviously, once again, this is a definition you're going to want to get down in your notes, okay? Nice and simple, starting out nice and easy. And once again, it's just how much stuff it makes up the object. Okay, keep it nice and simple, right? Students get this confused with weight because weight is the amount of gravity that pulls down on an object. Okay, so once again, you could have your mass is always going to be the same no matter where you are, but your weight may be different depending upon the gravitational pull of an object. Okay. So once again, like on Earth, this astronaut here has a mass of 100 kilograms, and his weight is about 980 newtons. But on the Moon, the astronaut has a weight of 162.2 newtons, and you can tell that because the Moon is about 1/6, okay, the gravitational pull of the Earth. So that's why the weight is different, okay. Once again, just some more examples of what we have on here. We have a person on Earth with a mass of 63.5 grams, okay, and his weight, all right, is about 623 newtons here on Earth, okay. That's about 140 pounds. That same person, though, their mass is going to be 63.5 on the Moon still. Once again, he's made up of the same amount of stuff, but his weight, okay, is going to be about 103 newtons, okay. Because once again, Moon has less mass, so it has less gravitational pull, so the weight is going to be lower on the Moon. What about on Jupiter? Well, on Jupiter, this person is still 63.5 kilograms. His weight is 1,582 newtons. Okay, that's because Jupiter is so massive; it has such a stronger gravitational pull that you weigh even more on Jupiter. And then finally, the Sun, okay, same mass, 63.5 kilograms. If you had some kind of heat-resistant something on to prevent yourself from being melted, your weight would actually be 17,418 newtons, or about almost 4,000 pounds. Okay, so once again, mass is the amount of stuff in the object, okay, and the weight, okay, is the gravitational pull on an object. Okay, so real quick, the volume is the amount of space an object takes up. Now, you've probably learned this once before, okay? You have your length, your width, and your height, and to calculate volume of a solid object, you're going to want to take the length, okay, multiply it times the width, and multiply it times the height, all right? Length times width times height, all right? And that will give you the volume of the object, all right? If you're doing an irregular object, then you're going to use the displacement method, okay, and we're going to go over that in a minute, okay. So density, your definition right up here, you want to get down the amount of stuff in a set amount of space, nice and simple, the amount of mass in a set amount of volume, however you want to say it. This equation box, all right, is on the front page of your reference tables, all right, page 1. And look, the formula is given to you right here. Density equals mass divided by volume. All right. Now, some of you have been taught the triangle method, okay, where you have the D on the bottom, the M on top, and the V on the bottom, kind of the D, M, V. And what's nice about the triangle is whatever variable you're missing, the triangle allows you to, recall how to find that variable. So, for example, if we're looking for density, density is going to be mass divided by the volume, okay? So, mass divided by volume, all right? Let's say we wanted to find the volume, and we were given the mass and the density. Well, you would take the mass, and you would divide it by the density. And then finally, if you were given the mass, if you want to find the mass and you were given the density and the volume, you would calculate the mass by taking the density and multiplying it times the volume. So your animation, real quick, I just want to show you how you can calculate, density if you were to do this in a lab setting. So you would take your object, okay, this little cube here, and you would mass it out, and this is a mass of 78.12 grams. Okay, so now you have a mass. Now let's say we wanted to find the volume of this object, and we wanted to use the displacement method. Okay, so what we would do, all right, is we'd take about the graduated cylinder, all right, and we'd pour the water into another graduated cylinder until we got exactly 50 milliliters. Okay, so we want exactly 50 mils here. All right, then we're going to take our sample and we're going to drop it into the graduated cylinder. Okay, it may take a couple tries because this animation is being a little funky, but there it goes. It's nice and in. Let's zoom in. Let's look at the bottom of the meniscus. Okay, now right here, it's kind of in between. Looks like 59 and 60. I would call this 59.5. Okay, so we have a mass. Okay, we have a volume, and now we can calculate, exactly what it was. So once again, our mass, 78.12. So in the calculator, all right, we're going to take 78.12 grams, and we're going to divide that by our volume of 59.5 liters. And we're going to get a mass of 1.31, let's round to the nearest hundredth, okay, grams per milliliter. Graphically, density gets a little difficult, okay, because all of a sudden students see a graph and they're like, oh man, how do I handle this? Well, let's take a look at this question here. It says, according to the graph, the density of pyrite is about what? Okay, well, this line is representing the density of pyrite, okay, right here. So you can actually take any point along this line and calculate the density. Okay, let's just pick a random point. Let's take 100. Okay, so here's our point right here. Its mass is 100. The volume is 20. Okay, so 100 divided by 20 is going to be 5 grams per milliliter. Okay, you could do it with any one of these points. Check it out. You could do 50 divided by 10. Okay, and you would get 50 divided by 10, and you would still get 5 grams per milliliter. It's a linear relationship. So basically, as the mass goes up, the volume's going to go up. As the mass goes down, the volume's going to go down. So any one of these points along this graph would actually give you the density of pyrite. Okay? So now it's saying if a sample of pyrite has a volume of 50, its mass would be what? Okay. So once again, all right, it has a volume of 50, which is down here. You can come on up, and you're like, wait a second, the line doesn't go there. Oh no, what am I going to do? Well, you can actually extrapolate this line. You could extend it, okay, to see where it actually meet up, and that would be the point right about there, okay? And they want to know what the volume would be, okay? So you would come across, and you would see, they want to know what the mass would be. You would see that the mass is 250 grams, okay? You could actually do this problem also mathematically. If you know that your formula is density equals mass divided by volume, and you just calculated what your density was, okay, then you'll be able to find out its mass using the triangle. D equals M over V. So, if we want to know what the mass is, okay, we're going to take the density and multiply it times the volume. So, mass equals, okay, the density is 5, okay, grams per centimeter cubed, and we're going to multiply that, okay, by the volume, okay, which is 50 centimeter cubed. All right. So if we take 5 and multiply it by 50, okay, maybe you can do that in your head, maybe you can't, but the answer is going to be 250 grams. Again, we got just grams here because the centimeters cubed cancel out. So we're left with 250 grams. So you could actually do this with the graph, extrapolate the graph, or mathematically, either way. Just don't forget with your density units, density is labeled using a compound unit, meaning it has, two properties, grams per centimeter cubed. All right. So don't forget these two. Okay. You'll lose points if you don't have your units. And for liquids, you're going to use grams per milliliter. Okay. Okay, guys, let's try a few practice problems to make sure you have this density thing down. Okay. Once again, a cube has a side that is 4 centimeters long. It has a mass of 128 grams. What is its density? Okay, so we know our formula is D equals M over V. We know, okay, our mass is listed in the problem. It's 128 grams. Our volume, though, is a little tricky. It says a cube has a side 4 centimeters long. So to calculate that, we actually have to do length times width times height, okay? And we're going to do 4 times 4 times 4, okay? So once again, we're going to do, all right, 4 times 4 times 4, all right? And if you want to pull up your calculator, you can, just to be safe, all right? You do 4 times 4 times 4, and that's 64, okay? So our volume, okay, is 64 centimeters cubed. So now we're all set up. We can just plug this into the calculator, and we can get 128 divided by 64, and that's going to equal 2, okay? So again, that's going to be 2 grams per centimeter cubed, okay? Looking at these two units right here. Another one, a rectangle has a length of 3 centimeters, a width of 2 centimeters, and a height of 1 centimeter. It has a mass of 120 grams. What is its density? Okay, so again, we're looking for the density. D equals M over V. Our mass, okay, it's listed for us, 120 grams. And our volume, again, length times width times height, or 3 times 2 times 1, okay, is going to be 6 centimeters cubed. So we pull up the calculator. We do 120 divided by 6. And we're going to get an answer of 20, or 20 grams per centimeter cubed. Once again, if you have any questions, guys, go back into this, okay? Pause it, take your time, practice with it, and stay tuned for our next PowerPoint on density. Thank you.